Yeah, we can start now.
Okay, sir. Good morning, everyone. My name is Athara Dukle. I'm the captain of Xanthium Racing Electric, and I'm here along with my teammate, Mr. Prasad Das, and we'll be presenting the cost report document. So before that, I'd just like to give a small introduction about our team. We are Xanthium Racing Electric, and this is the first time that we'll be participating in the electric vehicle arena. Our sister team, that is Xanthium Racing, has been a part of several competitions in the past, wherein it has also won several prizes. And just like Xanthium Racing, we are from Mumbai and are fellow students of Don Bosco Institute of Technology. Now, moving forward. So the parameters that we have considered while considering the entire assemblies and sub-assemblies are the process cost, which is the cost incurred due to certain processes, the raw material cost that was incurred while buying the material for making the parts, fastener cost, that is the need of nut and bolt for fastening of certain parts, tooling cost, that is the cost that is incurred due to usage or changing of certain tools, then the unit cost, which is the overall cost that is incurred due to the manufacturing of the part. Now moving forward, this is the cost breakdown of the sub assemblies that we have. Our entire card that we have built is of around 1,63,000, out of which the bifurcation has been presented on your screen, out of which the maximum part goes for the electronics and wirings, which mainly comprises of the batteries and the battery pack and powertrain as well, which consists of the motor. Then third in place, we have the chassis and bodyworks, which accounts for around 24,000, which includes the pipes and the processes that have been carried on upon them for making the chassis. Now moving forward, this is the cost breakdown of the chassis and bodyworks that we have had. The process cost, raw material cost, fastener cost, and tooling cost for each of the process has been mentioned from while making the chassis, and overall the unit cost has been mentioned here as well. Moving forward, so while making the chassis, we followed certain processes which were, so initially we just brought the long pipes which were then cut into smaller pieces of defined lengths. The diameter of the chassis is the standard 1 inch pipe, which was then cut into dimensions of lengths that were required depending upon the part that it will take shape into later on. It was then sent for bending to a nearby workshop. After procuring the parts, after the bending was done, we did the profiling of the parts so that while mating the parts for welding, the surface contact between the circular cross section and the flat section of the pipes is perfect. So after the profiling was done, we carried on with the welding. The cost breakdown of all the mentioned processes has been given here. The total process cost of this was rupees 4,880 rupees. Now moving forward, we'll talk about the steering assembly. Steering assembly is one of the major components when we talk about an automobile because it contains some moving parts and is based on a geometry that needs certain parts to move along a certain plane. Now, here I've listed all the components that we have used while actually manufacturing certain parts and have included all the parts that are either manufactured or bought while actually making the entire assembly. The cost breakdown and the percentage wise breakdown in the form of a pie chart has been given here as well, as you can see. Now moving forward, this is the cost that we have incurred while actually making the parts. The process cost was rupees 75. The raw material cost is 1145. Fastener cost is 110. Tooling cost is 50. The total cost is 1185 rupees. Now moving forward, we have also included some of the parts that we made in-house and what processes we used for making it. First is the tripod that is there within the center of the or as I can say, it is in mate with the steering column, and it is a crucial part in the steering assembly. So first we took a sheet metal of the desired thickness, we carried out cutting and grinding processes, after which we drilled the holes in the desired at desired distances and dimensions that were predetermined depending upon the design calculations that we had done. And then later on, we welded the tripod to a steering column. Now, moving forward, we have the steering wheel hub. This is an important part, as you know, that it will help us to hold the steering wheel to the steering column and will also help us in uh, moving the steering column in the form of rotation. So the processes that we have followed here is lathe machining, drilling, and welding. We first bought a part from outside, after which since the cross section of the steering wheel hub is circular, we use the lathe machine for the initial process, after which we carried on the drilling process, and then it was welded to the steering column to overall get the perfect desired outcome. Moving forward, we have the wheel assembly. The wheel assembly consists of certain parts such as the wheel, the tire, the stub axle, and the rear wheel hub. Now, the cost of all of these has been mentioned here, along with the pictorial representation in the form of a pie chart and also a small SolidWorks model that we had made. The cost breakdown has been given here, as you can see. We have included all the all the cost parameters that we had stated before: the process cost, raw material, fastener, and tooling cost. The unit cost for the wheel assembly has come forward to 3544 rupees. So the stub axle is one of the important part that not just plays an important role in keeping the wheel at a certain desired distance with the certain design parameters. It is also a part that in some way or the other helps us with the steering as well. It is a crucial part, and the processes that are involved for actually manufacturing this part is a little on the higher side. So it contains lathe machining, drilling, milling, and also threading, because we need the thread to hold the wheel to the stub axle. Now, moving forward, we have the knuckle. So the knuckle is the part which is welded to the chassis and it holds the stub axle within itself. And this is one of the parts that we have made in-house. First, we bought the material from outside of the desired dimensions plus some clearances, which will be negated after we complete the processes. We it went with First we went with the milling process, after which we went with the slotting process and then the drilling process. Now moving forward with the brake assembly, I'd like to invite my colleague, Mr. Prasad Das.
Once again, a very good morning to all of you present here. I will be explaining the brake assembly. The brake assembling pie chart has been presented here with the percentage how much cost is acquired by each of the components. While we can see the caliper is around 33.7%, while the rotor is of 12.3, brake fluid is 2.8, master cylinder 39.1, and fluid line is 10.2, and each of the cost in figures has been mentioned in the table. Next slide. The brake assembly cost includes the processes that has been explained by my colleague before. The process cost, which is around 50 rupees, the raw material cost, which is 2185, the fastener cost, which is 70 rupees, tooling cost 110, and the total unit cost of the brake assembly is around 4890. Rotor is made by us which is made by us. It is used by laser cutting. The process cost for it is around 550 and the labor cost is 50, so the total cost used for making a rotor is around 600 rupees. Powertrain consists of various parameters such as wheel, tire, stub axle, rear wheel hub, motor, throttle pedal, positive stop, throttle pedal, driver sprocket, driven sprocket, chain, drive shaft, and bearing bracket, where many of the parts that are being brought while some of them are manufactured in-house. Powertrain cost is the process cost for it is 2322, while the raw material cost for the powertrain is 905, fastener cost 10 rupees, tooling cost 130, and the unit cost for the powertrain is around 40,000. The parts that have been brought are the motor, sprocket, bearing, while the parts that we have manufactured in-house are drive shaft, bearing, housing, and chain guard. The drive shaft is manufactured by us in-house. The processes that we have used is lathe machining. So where we have get the pipe into the desired length and the diameter, and the gear cutting. Gear cutting is basically the splines that we have cut on the shaft where the sprockets can be mounted for transmission of the power, and the threading. Threading at the both ends of the drive shaft where we uh, attach the wheels, and along with that lock nut is used so that the tires don't move out. Electronics and wirings has listed over the in the tables. LV battery, wiring harness, brake light, sensor brake light, kill switch, brake over travel switch, start switch, accumulator isolation relay, RTD sounds, speakers, traction system, active light, tractive system, disconnect switch, accumulator management, life of POV cell, and pre-recharge resistor and controller. It also the cost of each of the components overall accurate is given in the percentage in the pie chart. Fits and finishes, the paint that we are costing for the vehicle is around 2000 to 95, and the stickers are around 400, and other accessories are 1400. Parts manufactured fully in-house of our EV kart are the chassis with roll cage, steering assembly, drive shaft, stub axle, knuckle, and bearing mounting. Thank you, sir.
All right, team, quickly open the course report that you have